We started with probability last week, and we talked about probability being the study of events which may or may not occur. And we also talked about the formula, which is P of E is equal to number of sample points over total sample points. Where E is an event, the probability of E occurring is notated by P of E. If E is an event that will occur, then E bar is the event that will not occur. Therefore, the probability of E not occurring is P of E bar. We also define sentence, which is experimental outcome, like equal likely outcome, sample space, and events. We also talked about some types of events, such as certain events, impossible, complement of an event, compound events, mutually exclusive events, and independent events. We also talked about the laws of probability, which is the probability of an event should be less than zero, should be greater than 0 and less than 1. The probability of an event should be greater than 0 and less than 1. And that means that it should range between 0 and 1. And the probability that the sample space will occur is equal to 1. So if you are sure that what you are looking for will occur, that will be equal to 1. And the probability of an impossible event, that event that will not occur, is 0. So those are the two restrictions, 0 and 1. Anything in between 0 and 1 means that it is probable to occur, or it is not probable, or it is less probable to occur. Now, if the probability of an event will occur is P of E, which we want to represent with R, then the probability of an event not occurring will be 1 minus P of E, which would be the same as 1 minus R. We also talked about the addition law of probability and the multiplication law of probability, but we'll go over them, the addition law and the multiplication law with the relative frequency today. Then we solve a lot of examples. Then we bring the chapter on probability to an end. I gave a question. So any question asked at this time, chat it in. Give me a yes if there's a question. Then I will mute you. Then you ask. Since last week, you have been able to go through probability on your own, I'm sure, and you know something about it. So if there's any question, give me a yes. If there's no question, give me a no. Hello. Okay, Sandra says no. Michael, no. Okay. Bridget, Gifty, Daniel, welcome, Fred. Okay, so since there is no question, I gave an assignment last week, right? Oh, okay. Some have done it. What about the rest who didn't do it? Yeah, I would like them to share. I'd like them to share, then we can continue. Okay, so I would like you to type the answer for your assignment. Oh, okay. That would be good. So if you can share your assignments for me to see, I'll be stopping my sharing, then we'll share them one by one. If you have done it, give me a yes if you have done it. Give me a yes if you have done it. Give me a yes if you have done it. Wow. Oh, okay. Then let's continue. Okay, so before I continue, mathematics, if you don't practice, you will forget. If you don't practice, you will forget what you have learned. So you have to be practicing so that when you get to the exams hall, when whichever way the question is put, you will be able to solve it. If you don't practice, you will not be able to get the variety of questions that can be asked. Is that okay? You will not be able to get that variety. So please and please again, try and work out a lot of math examples. When I was in school, what I was doing is I normally have to, one second, let me, okay. So I normally have to solve 5 math questions before and after I sleep. So if I'm about to sleep, I solve 5 questions. Okay, Basira said he has done it. That's nice. If I'm about to sleep, I solve 5 questions on math. If I wake up, I solve 5 questions on math, and it's always fresh in mind. That's how you learn math. Math is not like social studies that you can just chew and pour it. You have to be solving every day. So please, that's just an advice by the way. Okay, so for the laws of probability, we have the additional law of probability, which when we say additional law, it includes subtraction. Then we have the multiplication law of probability. So let's take them one by one. After that, we do the relative frequency. Okay, so for the additional law of frequency, this one, it will take you back to your set time when you were doing set in Form 1, okay? When you have something like or and you have end, what you have to do. When you have or and when you have end, what you have to do. Is that okay? So the probability of A or B occurring means that if you have the Venn diagram, if you have your Venn diagram, maybe this is A. Maybe this is A and this is B. Is that okay? So the probability of A or B occurring means that you are talking about everything B. So the probability of A occurring or the probability of B occurring will be equal to the probability of A. So if A occurs, A or B have occurred. If B occurs, it means that A or B have also occurred. And if A and B occurs, it means that A and B have occurred. So that's why we have the probability of A or B occurring is P of A plus P of B, the probability of A occurring plus the probability of B occurring minus the probability of A and B occurring at the same time. Is that okay? Then if the events are mutually exclusive, last week we talked about mutually exclusive events, which says that the event cannot occur at the same time. The event cannot occur at the same time. That's a mutually exclusive event. Those events cannot occur at the same time. Those events cannot occur at the same time. So if this event cannot occur at the same time, that means that the intersection is not occurring. Because if the intersection is occurring, it means A is occurring and B is occurring at the same time in the middle. Is that okay? But if A and B, if they are mutually exclusive, if A is occurring, B is not occurring. If B is occurring, A is not occurring. Therefore, that intersection, that's minus P intersection into bracket A intersection B, will not occur. That is what we mean by mutually exclusive. So P of A or B will be equal to P of A plus P of B. Any question? Okay. So that's the addition law of probability, and the multiplication law of probability is when we have if A and B are two independent events. So as I drew the Venn diagram, okay, so Abraham is saying I should go over. I'll let me finish the multiplication law, then I'll go over both of them. So as I drew the Venn diagram for the addition, I'm doing the same. So if A and B are independent events, then the multiplication law of probability says that P into bracket A and B. As you can see, for the first one, it was A or B. That's why the two circles were not intersecting. But in this instance, it says that A and B. So if it is A and B, then we'll be having P into bracket A intersection B. And that will be equal to probability of A occurring times the probability of B occurring. Okay. So that's the multiplication law of probability. Okay. Now let me go over again. So the addition law of probability says that if A and B are occurring, or both, if A and B are occurring, then the probability of A or B, that's the difference. Addition law of probability says that A, or then the multiplication law of probability says A and B. So if A or B is occurring, the probability of A or B occurring will be equal to the probability of A union B. That's whatever is in A will occur, or whatever is in B will occur. So that will be probability of A occurring plus the probability of B occurring, because you are saying that either A will occur or B will occur. So you have to know the addition of those two minus the probability of A and B occurring. Since we have the probability of A and B occurring, it means that if A and B occur at the same time, we will be double counting. Because A is occurring, B is occurring, we are adding it together. We will be having the same union here. But if A and B also, if they are not mutually exclusive, and they occur at the same time, then we have to subtract that one from it so that we will not be doing what? Double counting. Is that okay? Nice. Now, if events A and B are mutually exclusive events, then the probability of A or B occurring will be equal to the probability of A occurring or the probability of B occurring. As you can see, since they are mutually exclusive events and they cannot occur at the same time, we will not need to include the probability of A intersection B. That's for the addition law of probability. Now, for the multiplication law of probability, that's when we talk about the probability of A and B occurring. A and B occurring. If we say A and B are occurring, it means that they are not mutually exclusive. So in multiplication law of probability, mutually exclusive doesn't play here. So we have the probability of A and B occurring. If the probability of A and B is occurring, it is denoted by P into bracket A intersection B. That's A and B occurring. And to solve this, we multiply the probability of A by the probability of B. I hope you are clear. Hello, I hope you are clear there.
Yeah, we are clear.
Okay, thank God. Now let's move on to the relative frequency fast, then we can solve some questions. Okay, so relative frequency is all about finding the probability of a frequency. Okay. If you have done a mean, median, mode, and the rest, you see that you'll be finding the frequency of a set of numbers, a set of things. That's what relative frequency is doing here. So the probability of finding the frequency of a particular item or of a particular survey is what you call the relative frequency. And it is the same thing as the frequency of the event. That's when we check the formula for probability. That's the number of sample points over total sample points. In this relative frequency, we are checking the frequency of the event. That's how far or how much the event occurs over the total frequency. Over the total frequency. So it's the same thing here. Just that in this instance, we are not talking about individual events, but we are talking about a frequency of events. So let's take an example. In a survey of 150 families, so in this instance, 150 families were surveyed. 150 families, as you can see, families. So a family, 2 families, 3 families. A family can include people of 5 or 6. Another family can include people of 7. In the Japan family is about 20 something, only him. You understand? So we term that 20 something number of people or 23 number of people in that family as one family. Then we go to another family, we count them, they are 5. That's another family. So 1, 2, 3, up to 150 families were surveyed. And the survey was for families who have 4 children. The survey was for families who have 4 children. So if your family, your children are more than 4, then your survey, you are not part of that survey. So with only 4 children. Now, the number of girls were as follows. So these are the number of girls in that survey. So boys are not represented here. Now, the number of girls, the families who have 4 children but had 0 girls, it means that that family, they had 4 children, and all those 4 children were boys, and there were 8 families in total. The number of girls in a family in which the family, they had only 1 girl, which means they had 3 boys, were 41. When they have 2 girls, it means they have 2 boys, they were 55. When they have 3 girls, it means there is a 1 boy there, which means that it's left with 33. They were 33. And if they had 4 girls, it means that there was no boy in that family. They were 13. Now, the question is to estimate the probability that a family with 4 children will have A, 2 girls, B, no girl, C, 1 boy, D, 4 boys, and E, at least 3 girls. Okay, so let's try solving this question. I'll still be using this space. Okay, so as you can see, what is the total number of families that were interviewed? That's the total frequency. The total frequency is 150. Exactly, 150 families.
150.
Thank you very much. Thank you very much. 150 families were surveyed. Now, it says that we should estimate the probability that a family with 4 children will have A, 2 girls. So if the family will have 2 girls, that's the event of having a family who have 2 girls. That will be equal to what? And the frequency is 55, as you can see. The number of girls is what? 2. And the frequency is 55. So the event of the families having 2 girls is what? 55. So what is the probability of having a family with 2 girls? And that will be equal to 55 over what? 150. It's the same thing. The frequency of the event, that's what? 55. Thank you, Sandra. Thank you, Sandra. 55 over 150. Thank you, Sandra. And the answer, as Sandra has given, okay, another one, 0.4. Nice, nice, nice. I like my guys. That's nice. So as you have already given, that's what? 0.4. Now, what is the probability that there is no girl? No girl. B. No girl. B. No girl. B. No girl. Okay, Sandra, that's good. Abraham, that's good. God bless, that's good. Okay. So for probability, normally leave your answer in a fraction form. Okay. Normally leave your answer in a fraction form unless you are told to change it to decimal. Normally leave it in a fraction form. Okay, good. Yeah, now the third one. See, one boy. One boy. One boy. Nice one, Sandra. Jefta. Jefta, you can speak. Oh, it is a mistake. Okay, I think it is a mistake. Okay. Okay, one boy, I'm getting. Jefta, can you unmute yourself and speak?
11 over 50.
Oh, okay. Write it in the box. Okay.
Yeah.
Chat box.
Okay.
Chat box. Okay, nice answers I'm receiving. Nice answers. Okay, so let's do the third one. Okay, so let's do the third one, okay? If we are looking for the probability of the family having one boy, that means that the events of having one boy will be equal to the event of having 3 girls. Because if the family is having one boy and they only surveyed families with 4 children. So if the family is having one boy, that means that the family will have what? 3 girls. So therefore, the event of having one boy, that's the event of having 3 girls, which is the same as the event of having one boy, will be equal to 3 girls is what? 33. So we have 33 divided by what? 150. And that will give us 11 over 50. I hope you get it. Good. So that's it. Kudos to those who got it. Those who didn't get it, better luck next time. Now the next one is the event that the probability that a family with 4 children will have 4 boys. If the family will have 4 boys, what's the probability that the family will have 4 boys? Four boys. Nice one, nice one, nice one. Okay, so for the last one, I want to see everyone's answer in the comment section. For the last one, I want to see everyone's answer in the comment section. I want to see everyone participating in the last one. So Jephthah has already sent his. At least 3 girls. I want to see everyone's answer. At least 3 girls. We have 12 participants. That's 10 to be precise. At least 3 girls. Okay, Sandra has sent us. Sandra has sent us. I'm still waiting for answers. So Jephthah and Sandra have sent. Abraham, Bridgetta, Daniel, Freda, Kelvin, Michael, God bless, and Basira. I'm waiting for your answer. Okay, God bless has brought his. Nice. Daniel, Kelvin. Daniel has brought his. Kelvin, Michael. Basira, Abraham. Abraham has brought his. Bridgetta has brought his. Yeah, correspondent has brought his. Michael has also brought his. That's nice, that's nice, that's nice. Okay, beautiful. And now let's solve it. Okay, so the probability of having at least 3 girls. That's the event of having at least 3 girls. Means that we will want to have 3 girls or more. Exactly. So the list is that the family should have about 3 girls. Is that okay? So it means that the family should have 3 girls or more. That's the list. At least 3 girls. Therefore, we are going to play with this one. 3 girls or more. If you remember very well, the addition law of probability or is there. So 3 girls or more means that we'll be having the probability of having 3 girls or more, and the more is up to what? 4 girls. So 3 girls or 4 girls. And that will be probability of having 3 girls. What's happening today? Plus the probability of having 4 girls, which will give us the probability of having 3 girls to be what? 33 over 150. And the probability of having 4 girls to be what? 13 over 150. So solving this, you'll be getting 46 over 150. And that will give us 23 over 75. I hope you understand it now. Any question? If you have a question on it, let me know in the comment section or raise your hand. Any question? Good, good, good. Okay. So since we all get it now, we'll continue from here. Now let's come to our trial questions. Okay, so Sandra is asking, what of if the more are 2? If the more are 2, so if you have 2 mores there, then you will still add them. Is that okay? Or isn't that what you're asking? Sandra, can you unmute yourself so that let me unmute you, then you can ask the question, then I can answer it well. Hello, Sandra.
Hello.
Yeah, Sandra.
Yes.
Yeah, your question is it if you have maybe 3 or more, and the more you have 5 and 6.
Yes.
So with that you still add them, okay?
Okay.
Yeah, that's it. You still add all of them. So for example, if there is another one here, which is 5, and maybe we have 12, there is another which is 6, and we have maybe 10. Is that okay? So 3 or more, that is from 3 upwards. So you add all of this, then you divide by what? 150. You add 33, 13, 12, and 10, and you divide by 150. Is that okay? Okay, so Bridgetta said I should go over the 3rd question, which is one boy. One boy. I think Gifty is having a problem with her network. She can't connect. Okay, so for the one boy, now the sample was made for 1 second. People are now joining. The sample was made for families with 4 children. Okay. So the survey was made for families with 4 children. Now, in these families with 4 children, they have 4 children, and we are looking for one boy. If the family is having one boy, so if the family is having one boy, and we are looking for 4 children, that means that the rest of the 3 are girls. Is that okay? The rest of the 3 are girls. So if we are looking for only one boy in the families, that means that the rest of the children will be what? Girls. And that will mean that 3 of them are girls. So the probability of finding one boy, which is P of finding one boy, will be the same as the probability of finding 3 girls. It will be the same as the probability of finding 3 girls. That's why the probability of finding one boy is equal to the probability of finding what? 3 girls. I hope you get it now, Regita. Therefore, you'll be getting 33 over 150. Bridget, I hope you get it now.
Yes, sir.
That's good. That's good. That's good. Okay, so we can now move on to our trial question, which you'll be doing most of the solving, and I'll be doing most of the, oh, nice one, nice one, nice one. You have done well, okay? Aha, let's make the class entertaining as such. Okay, so an unbiased die. An unbiased die. When we say a die, we are talking about Ludo die, okay? 6 Ludo, that's what you are talking about. Okay, so an unbiased die and a fair coin. When we say a coin that have 2 different ends. So we have the head and you have the tail, different drawings, not the same drawing. So an unbiased die, that's 1 to 6, and a fair coin are tossed once. It means that they are tossed at the same time. Is that okay? They are tossed at the same time. What is the probability of having a prime number and a head? An even number and a head. A score less than 3 and a 2. And D, a score more than 3 and a 2. Yeah, okay. So my job here is to help you get the sample for this event that will take place. After that, the rest of the question is yours. Okay. So can someone help us get? Can someone help us get the sample for this event? Anybody, you can unmute yourself and tell me the sample of this event. That is if an unbiased die and a fair coin. Okay.
Sir.
Yeah.
Sir. Okay, for the unbiased die, we have 1, 2, 3, 4, 5, and 6.
Okay.
Then the fair coin is a head and tail.
Okay. Thank you very much. Thank you very much. So for the unbiased, that will be having 1, 2, 3, 4, 5, and 6. And the fair coin, you'll be having either a head or a tail. So if they are tossed once, you can have the sample because you can have either a 1 and a head. So 1 head, or a 2 and a head, 2 head, or a 3 and a head, 3 head, or a 4 and a head. You can also have a 5 and a head, or a 6 and a head. So this is the sample that you can get when it is a die and only the head. And you can also get, if they are tossed once, you can also get a 1 and a tail. You can also get a 2 and a tail. Can also get a 3 and a tail. Can also get a 4 and a tail, 5 and a tail, and 6 and a tail. They are the primary rhymes. Is that okay? I hope you get it.
Yes.
Give me a yes if you understand.
Yes.
Yeah, Jephthah is getting it. That's good. That's good. Give me a yes if you are getting it.
Yes.
Vegeta is getting it. That's nice. That's nice. That's nice. Who else? The rest doesn't mean that you're okay. Sandra is getting it. Sandra is getting it. Sandra is getting it. Daniel has. Oh wow, wow, wow. My guys are good. My guys are good. That's good. Okay, so as we have found the sample, so this is the sample from one head to 6 tail. Use it to solve the question there. That is, if the unbiased die is a prime number in a head, an even number in a head, a score less than 3 in a tail, and a score more than 3 in the tail. I'll be waiting for your responses, and I will give you, wow, what a wonderful work, and the rest. I'll even clap for some of you, don't worry. So I'll be expecting your responses any moment soon. The answers to them. Good one there, Jephthah. Wonderful, 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 wonderful. I like it. Vegeta, nice, 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 nice one there. Nice one there. Sandra, beautiful work done. Beautiful work done. Beautiful work done. Reggie, second one, nice one. Gifty, Frida, Daniel, Michael. Mina is not yet connected. Basira, I'm still waiting for yours. Nice one, Brigita. Nice one, Brigita. Frida, Daniel, Basira, Gifty, Kelvin, Michael, Winner. Winner is now connected. Welcome. So 2 more minutes. Kelvin, nice one there. Nice one there, Kelvin. Nice one there. You have 1 more minute. Brigitta, nice one there. Nice one there. Nice one there. Okay. Can we do it now? Okay, let's do it now. Nice answers, all of you. Nice answers, those who tried. Let me clear everything, then we can start. Okay, so the sample size will be what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's the sample size. So the sample size will be 12. Let's put that in mind. Let's put that in mind. So the sample size is 12. Now it says that the probability A says the probability of having a prime number and a head. The probability of having a prime number and a head. So what are the prime numbers in this? So the event of having a prime number, which is the prime numbers are 2, 3, and 5. Then the event of having a head is equal to a head. So the event of having a prime number and a head will be equal to a head, that's the prime number and a head. That's 1. That's 2 and a head. 3, which is a prime number and a head, that's 2. Then 5, which is a prime number and head, that's 3. Making what? 3 sample, or making it 3 events. Therefore, the probability of having a prime number and a head, let me represent it with P and A and H, will be equal to what? That's the sample, which is what? 3. All over the total sample, which is what? 12. So that's the answer for the prime number and a head, which is 3 over 12. And that will give us what? 1 over 4. Well done to all those who had it Those who couldn't get it, I hope you know your mistakes now and you correct it when the time comes, okay? That's nice. So that's for the first answer, 1/4. Now for the second one, which is B, we want an even number and a head. We are using the same format, which is even numbers here will be 2, 4, and 6. Then we will be attaching head to it. So 2 head, 4 head, and 6 head. As you can see, it's the same thing, which is what? 3/12. Is that okay? 3/12. And when you simplify it, you'll be getting 1/4. So it's the same thing as the first one. C says that a score less than 3 and a tail. A score less than 3 and a tail. So if you want to get a score less than 3, it ranges from 1, 2, 3, 4, 5, and 6. These are the scores. And we want to get a score that is less than 3. That means that the score which should be less than 3 will be 1 and 2. The first two, 1 and 2. 3 is not passed because 3 is what? A score on its own. So you'll be having a score less than 3 and a tail. That will be 1 tail and 2 tail, giving us 2 events. So you'll be getting 2/12, and that will be equal to what? 1/6. Kudos to all those who got it. Those who couldn't get it, you know your mistakes now. Well done, all of you. Then the fourth and final one, which is a score more than 3 and a tail. If you want a score that is more than 3, it starts from what? 4. So 4, 5, and 6. So a score more than 3 will be 4, 5, and 6, and that will give us 3. And a tail will be attached to it. That will give us 3/12. And that will give us the same 1/4. I hope you get it. Well done, all those who were able to participate in this short trial question. The next one is yours. You can start. Let's start working on this one too. Okay, so for the second one, any question for the first one? Any question? Any question for the first one? Any question for the first one? Okay, no question. Let's continue. So the second one, you'll be constructing the table yourself and you use it to answer the question yourself. 2 fair dice, A and B, each with faces numbered 1 to 6, are thrown together. 2 fair dice, A and B, each with faces numbered 1 to 6, are thrown together. A is construct a table showing all the equally likely outcomes. You have to construct a table which shows all the equally likely outcomes that can occur in this event. B, from the table, list the pair of numbers on the 2 dice for which the sum is 5, 10, more than 10, at least 10. Let me put this on there. Sorry. I is 5. I is 10. I is more than 10. IV is at least 10. Okay. So you can start work now. You can construct the table on your own. Your answer will show that you really constructed it well or not. Okay. So you can start work now. I'll be expecting your answers in about 7 minutes from now. Frida, nice one there. Jefta, nice one there. Sandra, nice one there. Okay, Michael, we'll come to solving it, okay? We'll come and solve it for you. Abraham, nice one there. Who else has Gifty, nice one. Winner, I'm not seeing you. Okay, Winner is in. Winner has submitted some. Nice one, Winner. Okay, Winner has submitted another one. Okay, there's someone waiting to be admitted. Yes, Sandra is done. Sandra, you are done. Nice one there, Sandra. Yeah, Jefta is also done. Jefta is also done. So let's solve it. Okay, let me share a new screen. Okay, so the first one says that you should construct a table showing all the equally likely outcomes that can occur in this instance. Okay, so you'll be having one. You'll be having 1, 2, 3, 4, 5, and 6. Is that okay? This is one of the outcomes that can happen. That's when the die is thrown. That's for the first one. Then the second one too is 1, 2, 3, 4, 5, and 6. This is the second die. So this is for the first die, and this is for the second die. Is that okay? Now, these die are thrown at the same time. Is that okay? So we'll be having a probability of getting 1 and 1 at the same time, 2 and 2 at the same time, 3 and 3 at the same time, 4 and 4 at the same time, 5 and 5 at the same time, or 6 and 6. You can also get 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. You can get these figures. Let me share a Microsoft Word document, then we can use that to answer. Okay. Let me share a Word document. Give me a second. Okay. Okay, so can you see my Word document? Okay. So these are the dice. We have 1, 2, 3, 4, 5, and 6. Is that okay? And for this side too, we'll be having 1, 2, 3, 4, 5, and 6. Let me.
I think you have to shift the once more.
Yeah. Nice one, Sandra. Thank you very much. Yeah, she is. She is very, 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 very intelligent. Okay, so these are the possible outcomes. So let's say the first one is for die A. Is that okay? And the second one is for die B. Okay, this first row is for die A, and this second row is for die B. Is that okay? So in this instance, we are going to get a 1 and a 1. You are going to get a 1 and a 1 for the first one, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, and a 1 and a 6. Is that okay? As you can see, when you throw these dice at the same time, you can get 1 and 1, which is a 1 and 2, 1 and 3, 1 and 4, 1 and 5, then 1 and 6. The same thing will happen here, which will be 2 and 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5, 2 and 6. Who understands? Who is getting the concept here? Good winner. Hey, sorry, please give me 1 second. Let me reject this for now. Okay. Then with this one, you'll be having what? 4 and 1, like as it is. Bridget is back. Let me admit here. Okay, so these are the possible outcomes. These are the possible outcomes that. Yeah. Sandra, I saw your first answer. It was well done. It was well done. Okay, very well done. That's good. That's good. So this is the possible outcomes that you will get. These are the possible outcomes that you will get when you throw a die or two dice once. If you throw two dice once, you'll be getting either 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. And in getting this, you can get a 1 and 1. So you throw the die once or both dice once. You can get 1 and a 1. You can get a 1 and 2. You can get 1 on one die and 3 on another die. You can get 1 on one die, 4 on another die. You can get 3 on one die and 3 on another die. So this is what we talk about when we say the possible outcomes that you get from that throwing of a die. Is that okay? Now, with that being said, the second one is from your table, list the pair of numbers on the two dice for which the sum is 5. So this one is not a probability question. It just asks you to list the pair of numbers. List the pair of numbers. It didn't say what is the probability of the pair of numbers. No. It just said list the pair of numbers. So we are just going to list. Is that okay? And as in listing, it says that the first one says that is the sum of them is what? 5. So if the sum of them is 5, this one is not 5. 1 and 1 is not 5. So the sum of them is 5. You'll be getting 1 and 4. We'll be getting 1 and 4. We'll be getting 2 and 3. Thank you. Then what else?
3 and 2.
We're getting 4 and 1. What else?
It's finished.
That's all. Is that okay? So this is the list of. So you just have to list them. 1 and 4. 2 and 3. 3 and 2. 4 and 1. Is that okay? And the second one says that the sum is 10. If the sum is 10, all these ones are disqualified. All these ones are disqualified. From here, they are disqualified. Here,
4 and 6.
4 and 6 is qualified.
5 and 5.
Thank you. 5 and 5 is qualified.
6 and 4.
6 and 4 is also qualified.
Ready.
Is that okay? Now the next one says that it is more than 10. If it is more than 10, then it means all these ones are disqualified. From here, from where you answered, these ones, they are disqualified. It means that the only ones that are more than 10 is what? 6 and 5. 5 and 6, sorry. Thank you. Then you have what? 6 and 5. Then you have what?
6 and 6.
Oh, I like how the class is becoming entertaining. I like it. 5 and 6. 6 and 5. 6 and 6. Okay. Now the next one says that it should be at least 10. At least 10. Which means that it should be 10 or more. Exactly. At least 10. It means that the least that you can get is 10. So the sum should be at least 10. That's 10 or more. And that will be the last 6 that we talked about. That's this ones and this. Is that okay?
Yes.
That is our at least 10. Now the next one is the probability question. That is C. it says that find the probability that the two dice. I hope you can see my screen now.
Yes.
Good. Okay, so we have to find the probability that we will get what? I, different scores, and I, same scores. If you are going to get same scores, let's do the same scores first, then after I'll use it to do the different scores. So what's the sample here? What's the sample here?
36.
36, that's right. The sample is 36, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all of this one. So the ones from this side to this side, this is the sample we are working with. 6 by 6 will give us what? 36. So the sample is 36. I hope you get it. Okay. Now we have to find the probability that the die will show different scores. If the die will show different scores, then 1 and 1 is the same score. It's no different. So let's give it a different color. The rest, if you are giving colors, you will suffer. Okay, so 1 and 1 is the same score. 2 and 2 is the same score. 3 and 3 is the same score. 4 and 4 is the same score. 5 and 5 and 6 and 6, they are all the same scores. So we have to subtract the same scores from the total number of scores. And the same scores is what? 6. 1, 2, 3, 4, 5, 6. So the event of having different scores will be equal to the event of having the same scores minus the event total scores and that will give us the total score, which is what? 36.
36.
The same score is what? 6. And that will give us 30.
30.
Exactly. That will give us 30.
Right.
So that's the different scores. So that's the event of getting different scores. Therefore, the probability of getting different scores will be equal to 30 over 36, and that will be equal to what? 5 over 6. Exactly. And the second one states that same scores, and we know that and we know that the same scores is what? 6 over what? 36. And that will give us what?
1 over 6.
Okay, so let me mute for the C part. And for the D, it says that find a probability that the sum of the numbers on the die is 5. So this one we are going to work with these ones. Is that okay? But in this instance, we are not going to list them. We are going to find what? The probability. So the first one says that the sum of the numbers on the die on the two dice is 5. And we have already found out that the sum of the numbers, this is the list of them. Is that okay? And they are 4 in number, which is 1, 2, 3, and 4. Is that okay? So the probability of having the sum to be equal to 5 will be equal to 4 of the items over 36. Is that okay? And that will give us 1/9. The second one, which is sum will be equal to 10, will give us 1, 2, and 3. So we have 3 there, right? So that will give us 3 over what? 36. And that will be equal to 1/12. The next one says that the sum is more than 10. The sum is more than 10. And that will be equal to what? These ones. 5 says this, and it gives us 3 items. So that will give us 3/36. That will be equal to 1/12. Then the last one, which is the sum should be at least 10. That's 10 or more. I don't have the greater sign or equal to symbol here. And that will give us this 3 plus this 3, and that will give us 6. So 6/36. And that will be equal to 1/6. I hope you get it now. Okay, good one there. So, with this same question, an assignment for you today too. Find the probability. This is an assignment, okay? Sum is equal to an even number. The sum is equal to an odd number. Sum is equal to odd number, which is greater than 6. Difference is 3. Difference is 10. Okay, so that's your assignment. Okay, Sandra.
Sir, please, I don't get the difference is 3.
Okay, so the difference of the numbers on both die will give you 3. So if you subtract them, you get 3. I hope you get it now.
Okay, thank you.
You're welcome.
Yes.
Okay, so that's it for today. Thank you very much. Today has been an awesome day.